Hello to everyone. It's my pleasure to present you our presentations on topic investigation of the color reproduction quality of inkjet digital printing machines. Industrial digital inkjet printing machines are increasingly entering commercial printing, label, packing, etc. The quality of printing and the speed of inkjet printing machines are constantly increasing, but in a number of industries such as packing, labels, etc., there are increased requirements for core reproduction quality, which requires additional and in-depth research. The main purpose of this article is to study the different quality indicators of the most widely used digital inkjet systems. For the purpose of the experiment, were used from the most commonly used in practical materials such as regular matte and glossy coated paper, uncoated white paper, etc. Several test forms with a large number of test charts and various control elements are printed on the aforementioned digital printing presses on different media. For the purpose of the experiment, we have modeled special test forms with specialized scales and control elements for colorimetric tests and assessment of color characteristics of simulate Pantone colors of inkjet digital printing presses, test charts to generate ICC profiles, charts for colorimetric analysis of color characteristic for a digital printed image, image with distinct colors, precision control scales for estimation of color reproduction accuracy, gradient precision, etc. Densitometric analysis pages for estimating of density of slits, tone value increase, print contrast, and etc. To complete the test, we have used a premium inkjet printing system as offered by one of the segment leading brands. The fundamental task in building a color profile is the almost precise reproduction of the digital original. The derived ICC profiles, on the base of which we have tested the FOGRA 51, FOGRA 52, FOGRA 29 and FOGRA 39 ranges, are rooted on the characterization data as published on the FOGRA website. The profiles are generated with optimal color separation conditions as per ISO standards 12647 to 4004 and 2013 year. Part of the scale used are present in the pictures. You see the next slide. This is a part of the testing forms used during experiments. Before printing, the test edition machines are calibrated according to manufacturer's instructions with the aid of spectrophotometer. In order to perform a comparison of the color gamut for the used materials in the used inkjet digital machines, it is necessary to get both 2D and 3D visualization with a standard ICC profile, FOGRA 29 and FOGRA 52 for uncoated papers, and FOGRA 39 and FOGRA 51 for coated papers, so that one can gain visual idea of available color gamut. To get the 2D and 3D visualization of the ICC color profiles, we have used the two specialized softwares. This is the Profile Maker 5.0 and Coloring Pro 3.0.3. The test completion comprehends to the following parameters: testing and comparing the 2D cross sections of color gamut, testing and comparing the volume and shape of 3D color gamut, calculation and compression comparison of the core gamut volume delta E per third. We test the 3 printing presses. This is the Durstau RSC 330, Gauss Wabelfire 340 and HP DesignJet Z6800. We were able to calculate the core volumes from printing results for the used substrate and to compare them against the reference values for the corresponding Fogler standard. One important function which is used to visualize the cores as reproduced by any given machine is the 2D and 3D representations of the respective core gamuts. The 2D representations of core gamuts with different cross sections along the L axis of the CLAP core space allow for good visual comparison of cores in light, mid and dark tones, as well as comparison of large number of core gamut at once. The 3D representation of core gamut allows a complex visual assessment for the 3D body of the core gamut. It is appropriate for the visualization and comparison or two core gamuts. On the next few slides, different sections along the L axis are presented for the respective digital printing systems compared to the corresponding Fogler standard. In this slide you can see the graphic representation and comparison of 2D core gamut with different values of L over uncoated paper as printed and 3 digital printing presses. This is a different L and when L is 30, this is the dark tones. You can see the Fogler standard is outside in the printing press. The next slide we see the same but for Fogler 52 standard. This again is uncoated paper. Next one is the Fogler 39 and representations to 2D core gamut with different values of L over coated paper. And the next one is the Fogler 51 standard, again a coated paper. All digital printing systems have approximately the same shape of the 3D rendering of the core volumes. And this in this picture, this again for a Fogler 29, and you can see 3D visualization in LIB system of NIC profile. This for offset paper, this uncoated paper, and different printing press. In this picture you can see the Fogler 52 standard, again in the offset paper, and different pictures. This is the Fogler 39. And the Fogler 51 standard for different printing press. In this table you can see the delta per third. This according to these results, one can obtain the graphic as shown in the figures the next slide. This different unquad paper, quad paper, and the core gamut delta per third in different presses and different FOGRA standards. I don't read the conclusion because they are also in the following slides. The volume of text and articles is large, and I would not like to take up your time to present them. These big numbers and text. In the end, thank you for your attention. I wish you all the best at the symposium, and special thanks to the organizers of GRID 2022. Thanks again. If you have any questions, please read me in the email. Thank you.